Thank you, sir. I am Ms. Mahadev Agundi, Assistant Professor from Electrical Engineering Department, Sanjay Godavat University. I welcome you all. Good afternoon, everyone, and welcome back to the second session of today's STP. For second session, we have a topic: electric motor drives in electric vehicles. For this topic, we have today's resource person, Dr. Lenin NC, Professor, Deputy Director, Vellore Institute of Technology, Chennai. Now, I will brief about today's resource person. It's a great pleasure to me to introduce about today's resource person, Dr. Lenin NC. He is a professor, head, electrical machines and drives, Deputy Director, Electric Vehicles Incubation and Testing, VIT Chennai. Also, he is a senior member of IEEE. He is having 186 citations, 8 H index, 5 I-10 index. He published more than 100 publications. He is having more than 15 years experience. He completed his PhD from Anna University in electrical machines in 2006 to 2012. Now he is Associate Professor, Electrical Department, VIT University Chennai campus, India. Also, he is involved in various groups like design research, electrical motors and generators, the teaching professor, permanent magnetic motors. Like he is involved in various groups. When I searched about his publication, more than 100 publications he did. So such a great person who is giving a today's session. So I welcome you, sir, with this brief introduction on behalf of Department of Electrical Engineering, Sanjay Godavat University. So I welcome one and all, and I kindly request Dr. Lenin sir to start the session.
So thank you, ma'am. First of all, I thank Dr. Lenas to give me the wonderful opportunity. And as Lenas said, of course, we people are not busy, right? We are always free. And that is also for taking classes and lectures like this. Always we love to do those things. We are not like committed like Lenas. So we know personally about Dr. Lenas. So how far he is committed with his professional classes, everything we know, right? So I am one of the big fan of Dr. Lenas. So thank you, Dr. Lenas, so for inviting me. So I am very glad to have a set of people to discuss. Just this is going to be a discussion, right? So everyone is going to be happy after the discussion. And I know after the lunch how far it is very difficult as a teacher. So I know how far it is very difficult to see a presentation. That is one of the worst curse as far as students as well as the professors are concerned. Right? I believe I won't take much time. So hopefully it is going to be somewhat. It's a interesting one for discussion. It's open to discussion only, right? So I would like to share my screen. So my screen is visible, Dr. Lenas?
Visible, sir, visible.
Okay.
So make it full screen. Okay, fine.
So yes, sir. So what we are going to discuss about today is electric motors for electric vehicles. As everyone knows, and each and the new generations, people are thinking that so electric motors or electrical machines are going to be a dead subject. Why people want to talk about this thing again and again? So I hope it is not. We don't have a full stop for electrical machines. That is what my strong opinion is. Right? So let us discuss few things. Then we will get into a picture. And these are the things we are going to see. I don't want to take much time in that one. Fine. First of all, yes, of course, for the past 2 3 days, you people are fed up with this. Why we go for electric vehicles? So, for my knowledge, there are only 3 points why we are going for electric vehicles. And remember, I am going to talk only about my country, and I don't know about global technology and global platform. So, I want to talk only about my country, right? So, everything what I am going to discuss is about my country, right? So, the first of all, yes, of course, we need to reduce the pollution. We have different sort of pollutions, and if you see the Indian graph, right, see the red color indicates the poor quality of pollution, and we have a orange color, and we have a yellow color with a moderate and satisfactory. Right? So, and if you see, we have different sort of pollution component available in a single vehicle. Just have a car here, but if you take a two-wheeler, anything, so these are the particles present in every vehicle, ICE engine vehicles. So we have carbon monoxide, we have nitrous oxide, we have volatile organic compounds, we have carbon dioxide, we have particulate matter. So this altogether constitute for is the culprit for having this vehicle emission as well as global warming. And if you see, during 1970s, my oil production is around 11 million of barrels per day. Production is 11 millions, whereas usage is only 6 million barrel per day. Right? Whereas now we are in 2020, see the gap. Now the usage is around 15 million barrel per day, whereas my oil production is dipped for around 5 million barrel per day. So it's a huge gap, right? So our usage is more, whereas our production is going to become poor. And that is why the Indian government augmenting few programs called as National Electric Mobility Mission Plan, foster adoption and manufacturing of hybrid and electric vehicles, and Bharat State 6. That is for IC engines. Yes, sir. So you know what is electric vehicles. Any vehicle propelled by electric motor is called electric vehicle. Right? So few advantages with respect to IC engines. So if you go for the IC engines, see the IC engines efficiency, overall efficiency is not more than 20%. Whereas my electric vehicle efficiency is approximately 60%. So which is 3 times more than my IC engine. That is one of the biggest thing what we are looking for our future. And of course, it is going to be environmental friendly. But there is a lot of contrast for this statement because we are having a battery. Now, if I am having a battery, how I am going to dispose the battery after the battery get fully, the lifetime of the battery get over. So because of that, is there any problem for environment? So that thing is going to be a contrast thing people are discussing. But of course, at present, if you see in a raw manner, suppose it is going to be environmental friendly. We have a performance benefits like, so we have a smoother operation of the vehicle, less noise, and we have a strong acceleration. It requires less maintenance than IC engines. These are the few performance, so we are having the performance benefits we are having for our electric vehicles. And if you see the reduce the energy, of course, the energy dependency is going to get reduced because battery is the source. Right, so it is going to get the reduce the energy. So of course we need to have its charging stations. For that we need to depend the electricity. Right, so those are the things. And if you see electric vehicles, we have different electric vehicle terminologies. So we have a hybrid electric vehicle, plug-in hybrid electric vehicle, fuel cell electric vehicle, battery electric. And these are the different energy storage systems we are having for each vehicle. And if you see the expected growth in electric vehicles, of course, so this becomes unrealistic condition since because of our pandemic. So the 2020 graph is totally get rid of this one graph. So the prediction now is at least in 2025. So we have this much of millions vehicles on road, electric vehicles on road. That is our prediction. So if you see the graph, so the graph is gradually keep on increasing. And what are all the technical glitches we are having in India to introduce this EV? So the one of the most important one is charging infrastructures. So where we are going to fix our charging infrastructures. Recharging time. What is the time it will take? Say for example, if I want to fill my two-wheeler, if I want to fill my two-wheeler for a petrol, so the capacity, if it is a 15-liter capacity two-wheeler, hardly it takes 5 to 7 minutes to fill the entire tank. Whereas if you want to charge a battery, whether it takes the same time or otherwise more than that, how it is going to reach. Suppose if it is more than that, 30 minutes, 60 minutes to charge a capacitor, then no youngsters is going to prefer that one, right? Because as a mechanical life, nobody is going to wait for 30 minutes or 90 minutes. People are talking about swapping the battery, but swapping the battery, what is the problem? Where you are going to keep the old battery? In your vehicle, suppose if you keep in your vehicle the old battery, what happens? Then the weight of the system is going to get increased. So again the battery lifetime gets decreased. Suppose if you give your old battery to the charging station to recharge it again. So since we are in India, right, we don't know whether they are going to change anything your battery to some other battery, right? So we don't know those things. So those are the constraints we are having. And what will be the driving range? Suppose if I fill a 15-liter petrol in my two-wheeler, so per liter it will give 40 kilometers. So if it is 15 liters, then I can travel 15 into 40, nearly 600 kilometers without having any acid. Whereas if I am having a only battery, so whether it is possible to travel without having any glitch. And at present, you know about the cost of a battery pack, right? So if you go for a 12-volt battery for a car also, ICE car, it will cost around 7,000 to 9,000 rupees, right? So that much of amount of money is for battery. Suppose if you keep on extending the range of the battery, the cost is also going to be exponentially get increased. So we need a high power density motor. So how much the motor is going to be small, and within that small motor, how I am going to make the more power, and how I am going to make the integrated power electronics with precise control. So these are the technical glitches we are having as far as India is concerned. So if you compare with the components, compare with the ICE vehicles and with the components in the EV, right? So if you see the components, the IC engine itself it takes 30% and transmission itself it takes 25%. And other things it becomes another 45%. So if you take a component of EV, so battery is one of the major things which it takes 70% battery and management systems. So other things it is less than 20. So electric motor and drives combined together it is 25, and transmission, the entire transmission system components get reduced when comparing this one. Okay? So that is one of the biggest advantage why we go for electric. So what is the basic requirement for an electric motor in electric vehicles? What is the basic? So this is a basic theory. What a motor is? From the motor, what we are looking for forward with respect to electric vehicles. So one is we need a very high starting torque at zero speed. Very high starting torque. Say for example, 100 Newton meter, 200 Newton meter, more than that at a zero speed. And a strong overload capability. Why this is more specific to our Indian road is we know as far as Indian road is concerned, what happens? People, if it is a two-wheeler, except in urban areas, if you go for rural areas, what happens? In two-wheeler, they are going to ride minimum 4 members, right? So we can see those things in suburbs, in villages. Same for a car. If you take a car, instead of 4 persons or 5 persons, people are traveling 8 person, 9 person. So we need a strong overload capacity, and we need a high power and torque density so that the machine sizing is going to get reduced, and we need to have a wide speed range. So a machine is going to run at 100 rpm, 2000 rpm, 20,000 rpm, right? Different speed conditions we want to have. And almost in all the areas, I would like to work my motor at high efficiency rated, right? So altogether, my motor drive system should be high reliability, robustness, and reasonable cost. So everything I should have to satisfy. Then only it is possible to cover the customer. So if you see the electric motors in traction application, what are all the motors we can use? So we are using two different types of motors, synchronous and asynchronous motors. Of course, DC motors are overruled by for this particular application because of maintenance issues in commutator as well as in brushes. So if you see the asynchronous motor, that is induction motor, advantage is it is having a rugged construction. We don't have any permanent magnets, so the rotor can withstand for any temperature. So that is one of the biggest advantage of induction machine. And if you see the synchronous machine, we have four different types of synchronous machines applicable for traction. Switched reluctance machine, synchronous reluctance, permanent magnet synchronous machine, and BLDC, and the axial flux permanent magnet machine. So if you see SRM, one of the advantage of SRM is if you see the rotor, it is going to be a solid piece. So we don't have any magnets or windings. So you can operate your rotor at very high speed, some 50,000 RPM, 1 lakh RPM, it doesn't matter. So no need to worry about any temperature rise and all. So it should be a simple and robust structure. So if you go for a synchronous reluctance, same thing. If you see the rotor, it is similar to SRM. We don't have any windings or magnets. Instead of that, we are having only air barriers. So this is also having a advantage of operating at very high speed. So here in SRM, in stator, we are having a concentrated winding, where in synchronous reluctance, either we can use distributed or concentrated. Coming to permanent magnet synchronous machine, so we have a permanent magnet on the rotor, which makes the rotor more smaller, that is smaller in size. So the high power density and torque density are possible in PM machines. So and efficiency is slightly more than when compared with other three machines. And one of the new technology people are now using for traction applications are axial flux machines. So it should be a compact size when compared with radial machines, high torque density and reduced core requirement, so that the cost is going to get reduced. So these are the basics of induction machine. I just so what we did in VIT. So 7 years back, we bought all the machines. We bought BLDC, we bought axial machine, we bought SRM, we bought induction machine. So we bought almost all the machines of the same power rating. So what we did is we tested the machine practically, and what we found is this is what the consolidated comparison what we found in different motors. So if you take a torque density, so the best one what we found is PMS machine and PM synchronous, that is PM assisted synchronous reluctance machine. So likewise, so we tested with the different parameters and compared with the output. So we compared with the reliability, we compared with the robustness, we compared with cost, active mass, control aspects, converter aspects, thermal capability, manufacturing aspects, wide speed range, efficiency, fault tolerance. So many things we did. and we did a extensive comparison, and based on that comparison we made list which one is best, which one is good, which one is better on each and every aspect. So whenever my student is going to come inside my research lab, the first and foremost thing is he is going to see this one. And based on the application, this is not only for traction, just take it for a general application. And based on the application, he is going to pick what motor is particularly applicable for that particular application. That's it. Right? That is what the first thing we are going to do in our lab. And the second process, what we are doing is we are having a design process. And what is the design process we are carrying here is getting the requirement of the motor. So what is the requirement of the torque, power, RPM of the machine, and what will be the requirements of thermal, mechanical, electrical. So these 6 things we are going to get as a input, and based on that we are having a standard program, and based on the program we are going to design our machine. And once if we get a design values, we are going to model it in a computer. First analysis is we are going to do the electromagnetic analysis, where we can find what is the electromagnetic performance of the machines, like what is the voltage, what is the current, what is the eddy current loss, what is the other type of losses, what is the input power, what is the output power, what is the speed, what is the torque. So those things we are going to carry over in electromagnetic analysis. And once the electromagnetic analysis is over, we are going to transfer the results to do vibrations. And in vibrations, we are going to find what is the decibel of the motor is going to happen. That is, what is the noise of the motor, or the motor created, how far the motor is going to create the noise for different switching frequencies. That we are going to check. And the third and final one is we are going to do the thermal analysis, where we find how far the thermal increment is going to happen in my machine. So, based on our little experience, what we found is what are all the design challenges as far as electric motors are concerned. So, if you see the design challenges, as I already told, so we need a very high torque at low speed. So the design challenge at that particular case is we need to have a proper slot fill factor, temperature limit, slot insulation, properties of foam and magnet. So these are the things we need to take care. These are the things we need to take care if you want to satisfy very high torque at low speed. And if you see the reduced torque, the next one is challenge is design reduced torque triple. So for a reduced torque triple, so we need to have a proper choice of number of teeth, phases, slots per port, proper selection of switching strategy, controller switching strategy. And the next one is minimal air gap. And we have a contrast performance of this one air gap. If you reduce the air gap, yes, of course, efficiency of the machine is going to increase, but the problem is the vibration and noise of the machine is also going to get increased. So we need to have a we need to have a prioritize what is the correct length of the air gap we are going to do for this case. And slot insulation. So what is the insulation limit we are going to have? So we people know what are all the insulation the insulation thickness we are having. So we are having slot class A insulation, class B, class E, G, H, and nowadays we are having class M insulation also, which is going to have up to 200 to 20 degrees Celsius. And the next one is the machine design should concentrate on overall efficiency. So whatever the speed is going to operate your machine, I am expecting my machine to deliver 90% efficiency. So that is what the present expectation is. So we need to have a proper sizing, proper controller operation, and proper separation of DQ axis. So and how we are going to choose the magnetic property, and what are all the stacking factor, how we are going to choose the stacking factor, and what is the type of winding we are going to do, whether it is a distributed winding, concentrated winding, or hairpin winding. So what is the thing we are going to do? And the last and foremost important thing is, suppose if you go for a high current applications like traction four-wheelers, trucks, buses. So the current we are going to play with is for some 500 amperes, 800 amperes like that. So during that time, the current is going to increase for some 300 degrees Celsius or 400 degrees Celsius. There we don't have any insulation to safeguard our winding. So we need to reduce the temperature. So what we are going to do is we are going to incorporate a external cooling system with proper liquid flow in that one, either it is a water or oil, anything. So we have a different cooling arrangements, the cooling jackets with different materials. So what is the optimal one which is going to be used for that particular application? So these are the different challenges we are having before going to start our mission. We need to fix everything in a proper plane so that the end outcome is going to be the best one. So, as far as India is concerned, if you see the number of vehicles at 2000 up to 2019, so we didn't get the value for 2021. So up to 2019, as far as Indian domestic market is concerned, we are having 25 million of vehicles. So in that, 13% is passenger vehicles, 3% is three-wheelers, 4% commercial vehicles, and 80% is going to be two-wheelers. And what we did is, in our campus, we did a very basic survey. How many two-wheelers, electric two-wheelers and the three-wheelers are present in India? So we did a basic survey and we collected some technical specifications of each and every three-wheeler. So if you see the first three-wheeler, this is a Mahindra Electric. So we have a Trio SFT, Trio Yari, and E Alpha. And if you see the vehicle speed, this is the vehicle speed, and this is the type of motor used, and this is the power rating of the machine, and this is the battery they are using. Right? And we collect a few specifications, technical specifications. So similarly, we go for a low gear three-wheeler. Right? These are all available in Indian market. Remember that these are all available in Indian market. So this is Gaya motor. This is for kinetic green vehicles and Ampere vehicles in Coimbatore, Zenite Innovations Limited, Scooters India Limited, Plaudit. So they are having different power ratings. Each and every vehicle they are using different power ratings. And even in Hyderabad also, one of the new company explored in Hyderabad. It is Street Tech EV. Right, that motor is also there. So usually with autos. So we collected different three-wheelers, right? And similarly, we did the exercise for electric two-wheelers also. So we did with different companies available in India. So Ather is one of the emerging two-wheeler industry in market, Indian market. So they are using some 3.3 kilowatt power rating, and they are increasing this power rating now at present. And the Hero Electric, they are having different variations. A1 bikes. So other bikes we are having. And this is about a car. This is about four-wheelers. So these are all four-wheelers. Four-wheelers, and we have different models. So Toyota Prius, Chevrolet, Tesla, Nissan, Hyundai. So we have different models, and these are the types of EV or HEV, and what are the type of motors they use, and what is the peak power, peak torque, and maximum speed. Right? And we just collect this information in order to understand how we need to approach the motor industry, particularly EV motor industry, so that the commercialization is going to happen without having any hassle in time frame. So overall, what we collected is this is what the overall consolidated specifications of what the industries are looking for towards two-wheelers and three-wheelers. We are targeting only two-wheelers and three-wheelers. We are not targeting four-wheelers at present. We are only working towards two-wheelers and three-wheelers. So this is the minimum requirement for a two-wheeler and a three-wheeler. So what we did is, based on the requirement, we did a we choose different motors, BLDC, synchronous reluctance, induction, SRM, and we design almost all the motors for the specifications for the need of the industry. So this is what is 755 watt permanent magnet BLDC. These are the performance results we get. The efficiency map. So this is the product we developed. So this is the product we developed, and this is the so this is the frame, and this is the rotor. So magnets are attached in that one, and this is the stator, and this is the sensor. So we need a 1.4 kilowatt of BLDC. So these are the performance things, and the 1.6 kilowatt BLDC. So again, I go for a 755 watt synchronous reluctance machine. So this is the synchronous reluctance machine rotor with barriers. So 1.65 kilowatt synchral. So 2.2 kilowatt synchral. So again, I go with a 2.2 kilowatt with PM assisted. So I just inserted a few ceramic magnets inside the barrier, and I just want to check what is the resultant output. So these are my resultant output. So I did a thermal analysis for this one. See the thermal thing. So in coil, it makes red. So that is the maximum temperature. The maximum temperature is 130, 131 degrees Celsius. Whereas in rotor, it's in a brown color. So it is around 128 degrees Celsius. So I am using insulation H here. So insulation H means it is going to withstand up to 180 degrees Celsius. It can withstand up to 180 degrees Celsius. Whereas my temperature is going to be only 131. So my design is going to be, as far as thermal constraint is going to be, it is going to get here. So whereas on the surface of the stator, it is blue, so it is around 170, 180 degrees Celsius. So this is what the temperature rise. I assume that my ambient temperature is 30 degrees, so it is starts with 30. So and it settles with maximum of this 132 degrees Celsius. So I run the machine for 6 hours. I run the machine for 6 hours. That is 240 minutes. 240 minutes is 6 hours. So if you see the comparison, of 2.2 kilowatt machine, right? A comparison of 2.2 kilowatt machine, right? With and without a permanent magnet of synchronous reluctance, right? See the efficiency get increased by 6%. And if you see the beauty, the current is going to get reduced by nearly 50 amps, right? And mass is also get reduced somewhat by 2 kgs. And the estimated cost is somewhat plus or minus same. It won't be much, right? It won't be much. It is going to be similar, right? So that is what the difference we are getting. So I just make the comparison for other machines, right? And so this is a frame mount PM assisted machines for different power ratings. So 755 watts, 1.4 kilowatt, 1.65, 2.2. So for the stack length, mass, cost, everything I just compared. So similarly, we did a switched reluctance machine also. So this is the switched reluctance machine for 1 kilowatt application. This is for 1.5 kilowatt application. So this is again 2 kilowatt application. So this is what the development we did for 260 watt outer rotating SR. This is for two-wheeler. So this is what the production we did with the help of the industry, right? So we did this one, and and we tested the machine for the performance. So this is what the developed motor. This is for 1.2 kilowatt. So this is what we developed in our lab. So we did it for induction machine also. We developed the induction machine also for 1 kilowatt. This is for 1.5 kilowatt and 2 kilowatt. So we make a broad comparison between induction machine and the SRM for different power ratings. So for 1.5 and 2 kilowatts. So if you see the difference for 1 kilowatt, so the stack length is 16% more in the induction machine. So if you see the power is going to be 7% lesser than SRM. And if you see the total mass, 42% of the mass is going to be high in induction machine when compared with SRM. So similarly, we had it as a comparison for 1.5 kilowatt and 2 kilowatt machine. So this is how the advantage is going to be straightforward with using the switch reluctance machine. And this is what the prototype we did it for induction machine. So we did for a 1 kilowatt induction machine, right? So it's outer rotating induction machine. We did a outer rotating induction machine and we tested with the standard inverter, right? It's a 48-volt system, right? And we get some results through the D-space. So this is what the dismantled the induction machine is. So this is our research team. So we are having a set of people so for doing research here. So who belongs to research associates, BTech students as well as MTech students. So each and everyone they are doing with their own perspectives, own mission. So these are few members who are working with the different missions. And based on their outcome only, we are going to guide them towards the next level of research. So these are the people who are involved in our team. Yes, sir. So that's all about my presentation for today's session. So I just want to have a discussion with you people. So don't worry about the presentation. So you can have a discussion with me for anything related with the electrical machines. So not only related to my presentation today, so anything. So my discussions are open to audience now.
Dear participants, please discuss with sir if you have any doubts. Sir, nowadays our electrical vehicle rotor attached motors are there, no sir? That means which is at motor speed is same as our the speed of the motor.
No, that is what the outer rotating motor.
Outer
This is
rotor.
what, yeah, outer rotor. This is outer rotor motor.
Outer rotor
This is
motor.
outer rotor, and this
Okay.
is also outer rotor. The SRM what we shown here in this
Okay.
one, this is also outer rotating one.
Okay. Okay. Okay.
So which is going to directly fit it on the wheel, so that
Feel.
the
Okay.
wheel speed and the motor speed is going to be same.
Okay. Okay. So
This is
for
called
this.
as a direct drive system.
Okay. So for that we need one coordination control for differentials, no?
Uh, See,
Differentials.
differential, yes, few cases we need to have differentials.
Uh,
Yes, so that is also one extra component we need to add,
uh,
right? If it is for high power, like four-wheelers or trucks and all that. For
okay.
two-wheelers, you need not worry about differential and all.
Okay. Okay.
We don't have that much of complications in that one.
Okay, okay, okay. Actually, now I have gone through. I have also started to do some research in electrical vehicle. So
Okay.
that time it is mentioned that nowadays electronic differentiators are there for mechanical instead of mechanical differentiator.
Yeah, electronic is there. It's easy to install.
Okay,
Right?
okay.
But for three-wheeler and two-wheeler, the purpose is going to be very less.
Yeah. It is the three wheeler is very less. Yeah. Okay, okay, okay. Dear participants, any doubts? I think. I think all are not asking any doubts. Better.
Yeah, you can have any discussion, no problem. Don't worry.
Okay.
So whatever I know, I am going to share. Or otherwise, we can wind up. No problem.
Sir, one more thing I have a doubt actually.
Okay.
You have already told one brushless DC motor of 5.4 kilowatts and 48 volt input supply.
Yeah.
So now, if the 48 volt, if you applied, that motor speed will be rated speed,
Yes,
correct?
of course.
Upper
Yes.
bottom. So now when this BLDC motor nowadays it is I am asking this much 5.4 kilowatts power to carry that what is the size of the motor? It will be very less, no? As it is voltage is also 448 volt.
Yeah, the size is going to be fixed by means of the number of conductors and current we are going to inject.
Inject, yeah.
That
Okay.
is the thing, right?
Yeah.
So,
Uh,
yes, so say for example, you are talking about 5 point, which motor, what we designed is 5.4. We didn't design 5.
5.4 kilowatts. Yeah.
No, we didn't design 5.4 kilowatt.
If I'm
We
going
just,
to the PPT, I think maybe unknowingly I have noted,
I
but
think it is 2.2 kilowatt, not 5.5.
okay, 2.2 kilowatts. So okay. Then if we design, when we design this electric vehicle, how much that no our gradient force power, how much you are calculating? What is the slope of that angle?
10, so as far as our country is concerned, minimum
Uh,
is 7 degree, maximum is 10 degree.
oh, so it is sufficient. Oh,
Yeah. 10 degree is more than enough. 10 degree is
oh,
more than enough. Yes, of course, since this is India, right?
uh,
So this is, I am talking about only government norms, government bridges and all. So it is either 7 degrees or 10 degrees, not more than that.
okay. So if you consider hill area, it may be 45-degree may not come.
Yeah. That is what. Those are all off-road vehicles. We call that
Okay,
as off-road vehicles. So
okay.
the purpose for that particular vehicles are going to be different.
Different. Okay.
So that is what I said. So as far as government norms is going to be for
Uh, uh,
commercial, that is for on-road vehicles, it is
okay.
going to be some 7 degree to 10 degree.
Okay. Thank you, sir. Thank you. I think any other participants will have any doubts, please ask. I think they are
I hope, I think somewhat you, I can throw some light, basic.
Yes, sir, yes, sir. Actually, thank you so much, sir. The design parameters and all, it will be very helpful for the person who is doing electric vehicle actually. The design how to take this different parameters and all those things, and it is this seminar is very helpful for choosing the motor which is good for based on the application. As like you said, you have shown one clear chart in that lab, that so everyone should understand which motor can be used for this vehicle. So it is very much helpful for new researchers who are all doing the research in electrical vehicle. And thank you so much, sir, being with us and explaining the concept of electrical vehicle, and how that various importance of motors in various electrical vehicle. And thank you so much for being with us for 1 hour. So even though you have said that you are not the busiest person, but I know, I know, sir, actually, that you are down to earth. That's why you are saying like that. But anyway, thank you, sir, for accepting your invitation and being with us for last around
Thank
15
you.
minutes.
Yeah,
So, sir, thank you, sir. Thank you.
thank you so much. Thank you so much. Yes, thank you.
Okay, okay. Thank you, thank you, thank you. Thanks. Dear participants, the next session will start at 3 o'clock. Please be on time. Thank you. It is better, no need to leave. It is better that we can stop it only 5 minutes. Yeah, only 10 minutes more. A resource person will join start shortly. Please wait. Thank you.